Welcome everyone, and thank you for attending today's webcast, Teamwork with Autodesk Inventor AnyCAD and Inventor HSM. Our presenter today is Tad Whitchurch. He's the Director of CAD/CAM Training and Support with Hagerman and Company. Before we get started, I'll let you know that you're in listening only mode. If you have questions during the presentation, you can type those into the question panel on the right-hand side of your screen. They'll be addressed by Tad at the end of the presentation. As we close down the session today, you'll be prompted to fill out a survey, and we ask that you take a few moments to fill that out for us. Additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. And with that, I'll hand things over to Tad.
All right, thank you very much, Ashley. I trust everybody can see my screen. If not, just type something in the chat or questions pane. I'll open those up. As Ashley mentioned, I'm the sole presenter today, so go ahead and type in your questions. I just want to let you know that I'll be able to get to those at the end of the presentation rather than stopping and answering them as I go. It'll just make the flow a little bit easier. I have about an hour of your time, and I appreciate very much you taking time out of your day to sit in on this. We do our web events often, sometimes weekly, bi-weekly, on different topics, and Inventor HSM is one of those. We'll do tips and tricks and turning and milling and so forth. So stay alert to our website and our marketing emails as we'll have more of these events for you. They're not really intended to be training per se, but I do like to wiggle in some tips and tricks as I go. So with an hour, you just can't really train people on the software that well. So this is more me telling you about functionality that's available that you may not be aware of, or you may be aware of and have not used. So with that, I want to take the first few minutes here and hit you with some PowerPoints. This is not going to be lengthy at all. Be very short, and then we'll dive into the product and focus on the Inventor AnyCAD feature and the HSM feature. So today, Inventor has an AnyCAD feature. Some people may not be aware of that, and we found that a lot of people aren't. But it is there. It's a great feature. I'll give you a quick tour of that to start out. And then we're going to take and utilize both the Inventor AnyCAD and Inventor HSM and show how together those two work. And it's really great teamwork with the two solutions that you'll see here today. Before we get too deep, let's discuss a little bit about Hagerman and Company. If you've been on these presentations before, then I don't want to bore you here too long, but we are a company that's been an Autodesk reseller for just about ever. We've been doing 30 years in CAM experience alone, and we're throughout the Midwest. And we didn't start with Inventor HSM. I joined the company in 1988, and we were using SmartCam and EdgeCam and SDRC ideas, and now the Inventor HSM and the HSM works. I do want to make sure you're aware we do sell and support both the Inventor HSM and the Solidworks version, which is called HSM Works. So our staff is riddled with all kinds of technical skills from engineering, design, plant, and even CAM. So we have people on staff who've made chips, produced parts, and got our fingers dirty. So we're standing by to help if you need it. Just a quick thing on this Inventor HSM stuff. It's basically something that Autodesk purchased a while ago. It's not new technology that they developed. It's technology that they purchased. They did that with the Inventor HSM, and that's historically how they operate. You know, their simulation tools and so forth that we focus on also were purchased products. So my point in this is that it's not new technology. Okay, it's been around for a while. It's well matured technology, and there's basically three solutions. There's the CAM 360, and I don't know if that name, they change the name often, but you can run, with Fusion, you can run basically an Inventor-like product up in the cloud, so you're actually utilizing your web browser to design with Fusion, and Fusion then does have the option to produce NC code also. So, and then of course the HSM Works, which is a little different for us Autodesk resellers, but the HSM Works product works inside of Solidworks, and we're capable and ready to sell and support you and train you on that also. And then there's the Inventor HSM product. Now all of these products basically have the same engine under the hood, the Autodesk Iron kernel, if you're interested in knowing that. Why integrated CAM? It's just really, it's better for you, the user. There's simplified data structure. You're working right on the Inventor model or the Solidworks model. There's no DXF or IGES or any of that needs to take place. And we can really eliminate a lot of the steps that are used from a standalone CAM system, such as export, import, redefining setup sheets, redefining operations. All of that goes away with the integrated CAM. So your workflow from create to machine is much shorter with the integrated CAM solution. And people they'll freak out, you know, well, I don't know Inventor. You don't need to know Inventor to learn Inventor HSM, and that's a big deal. It helps, you know, if you need to work on a sketch or something, and we cover that in training, which I'll be getting to here in just a jiffy. A little bit about creating models. What we're going to do here is, and I'll do this from scratch so you can kind of see the whole thing happen, is I'm going to define a job setup. We'll define some operations. We'll simulate it, or as I like to call it, kind of a pixelator, so you can verify your tool path on the computer before you send it to the machine. So it's very simple to use, and one of the differentiators from us or the Autodesk HSM solutions and our competitors, and we know the competitors because you know, we've been around for a while, and heck, we sold some of them, so is that what we're finding, it's kind of like the old mechanical desktop days, hate to even say that, or the AutoCAD architecture, where functionality continues to be improved and added to all of these CAM systems. And what they're doing is they're putting it on top of what they have. And then the next release, they put more on top of what they have. So you're beginning to bog down and getting into a bit of an archaic user interface, and the program just gets bigger and bigger. With Inventor and the HSM solutions, it's all modern. The entire interface and functionality have been basically rewritten for modern day technologies. And the HSM solution, and I tell people this right up front, it's really intended to produce G-code quickly. So if you need to go from design to manufacturing quickly, then the HSM solution is the one for you. And the reason I emphasize that is because there's also clients that do huge lot sizes. So you program a part and then you're going to run it, you know, 1,000 times or a couple thousand times. And in those environments, you're really interested in tweaking every single second you can out of cycle times. The Inventor HSM solution can do that, but it's really intended more so to produce G-code quickly. So we don't get into actually getting down and opening the hood and touching the toolpath. We modify the toolpath, and I'll show you that. So you also, and we've seen this a lot since the HSM solution came out, is the expensive maintenance that some of our clients are spending on alternative CAM systems. And with the Autodesk way of doing business. It's a very affordable subscription plan, and the product is not nearly as expensive for the same functionality as we find out in the market. A lot of people charge you for a post. Posts can be complicated. A lot of times posts are written and they take months or years to do because every part's a little bit different. What we have with the HSM solution is a community post area, and if you're interested in learning more about that, let me know. But there's a website that gets updated posts constantly, and what I'm going to do is I'm going to take you to that real quick. Let's go up to Autodesk, cam.autodesk.com/posts, and I'm just using a web browser, in this case Chrome, and you'll see here that the list of post processors that are available to you are quite large, and you can grab any one that you want. If you have a UMC 750, you can download that post and go to work. If you're not sure, you can click on the sample and it'll pull up a print screen of a sample of how the G code looks. So they've done a real nice job here in producing this website for you to find post processors, and you can filter by milling, turning, water jets, lasers, plasmas. You can also filter for a post that was just added today or this past month or this past year, and also by vendor. So that's really nice, and it's something that we really appreciate from the reseller standpoint. So yeah, you don't have to pay for posts. Many of them are available. There's community posts out there. The software ships with just a ton of post processors, and I'm not talking a half a dozen or a dozen, but we're talking several different post processors. When you install it, there's a post folder, and in there are just a slew of different post processors. So again, our differentiators are the modern technology, the affordable price, community posts, and then also a big differentiator is training. We, as I mentioned, we're SmartCam resellers, EdgeCam resellers, SDRC, and we were needing 3-4 days of training to get people going on some of those solutions. And what attracted us to HSM was really two things, or three. It's the Autodesk product. The second would be the post processors, and then the third would be the learning curve. We're finding that you really only need about a day of training to get going on this product, and that's for basic mill and basic turn, and you don't need to be an Inventor expert to use the HSM side of it. Many companies have a design team and a manufacturing or programming department, and you don't need to get in and take a 3-day Inventor class and then a 2-day advanced class to start making parts with HSM. The training that we've been doing has almost, in all cases, been performed remotely, and we've been having wonderful success with that. Every training class, we get a training survey back from the students, and they're very happy with how it's working. They're now, they're dealing with a live instructor. It's not a video thing or anything. So while it's remote, the instructor is there with you, living and breathing instructor, and you can see his screen, you can hear his voice, and he can see your screen also if you run into trouble. So really the key points in just me taking a few minutes here to bore you with the PowerPoint is that when it comes to manufacturing or design within your area, that the Hagerman, Autodesk, and HSM combination is really a winning combination for you, and reach out to us and let us know how we can help you with that. So what we'll do, if I can get this out of the way here a little bit, there we go, is this is a little bit different presentation than what I've done in the past. We're going to focus on really just a couple things here, and one of those is the Inventor AnyCAD. So what I'm doing is I'm starting out in a non-Autodesk product. So, you know, slap my hand or whatever. But what we're in right now is a competitor. We're in a product called Solidworks, and we understand that from a manufacturing standpoint, many of our customers have to work and have customers who have and use different design solutions, and they need to be able to work with those and work with those efficiently. So with this presentation, I'm using SolidWorks. It could be Pro Engineer, it could be CATIA, it could be Solid Edge. It could really be just about any external or CAM or design software to show the Inventor AnyCAD features. So here I am in SolidWorks. This is just a file. It's called a simple file. It's a widget. We use that a lot. A 2D chamfer. It's a solid part using the SolidWorks format. So where do we start with this Inventor AnyCAD? Well, I'm going to pull up Inventor, and when we do an open within the Inventor product, it defaults to open Inventor files, but this drop down is huge. I guess it's a drop up. But anyway, you have all of the Inventor files here, but you can open up DWG files, CATIA files, Parasolid, Pro Engineer, Revit files if you need to, SAT files, STEP files, but we can also open up native SolidWorks files. So I'm an Inventor, and I'm going to go and open up that SolidWorks file. And we can verify it's the 2D chamfer.sldprt. So I'm going to go and open up the 2D chamfer.sldprt. Now when I hit open, this is where the Inventor AnyCAD takes off. So Inventor AnyCAD now looks and sees, let's go here, close that one down. How's that? Let's try that one more time. We'll open up the SolidWorks part, and this is basically the Inventor AnyCAD feature here. What you're seeing is that when we open up a file that's not an Inventor file, this is a native SolidWorks file, we have the opportunity to convert that file into an Inventor file, and this is what a lot of people do. But with AnyCAD, we can instead say, no, I would rather import that file and have it be a reference model. And this reference model option maintains a link back to that original SolidWorks file. So hopefully you're with me so far. So kind of like an X reference in AutoCAD or bringing in an assembly. So me opening up a SolidWorks file in Inventor, I hit OK, and it is still linked back to that SolidWorks file. So that is the AnyCAD feature that took off and allowed us to do that. Now what we'll do is we'll program this part, and I'm going to use Inventor HSM to do that. So we'll move over to the CAM environment, and the first thing that we need to do from within CAM is define a setup. And the setup basically is defining, are we milling or are we turning? And what's the model orientation? So I'm going to say that the z-axis is perpendicular to that, and the x-axis is along this edge. Now, you can flip the coordinate system here, or you can actually pick on the coordinate system on screen and flip it there also. So they've done a wonderful job here with the user interface. Now remember, I'm working on a SolidWorks model here inside of Inventor. Now from here I'm going to define the origin, or where do we set 0, 0. And I can pick using these black points on the corner and define where do we set 0, 0 off to machine this part. I can also coordinate and define the stock. In this case, I'm just going to use a relative box side and say there's no offset on the top or side. We're just going to really kind of worry about the inside here for this presentation. And I'm going to hit OK, and that defines the setup. So the idea here is that we don't want the design folks to be concerned with how a part sits on a machine. They do their own thing within Inventor and design it as they see fit or as they need to. And then when we start to make toolpath with it, we tell it how it sits on the machine. Now from here, what we have is we have the Inventor environment up top. The HSM added one ribbon. So this is all Inventor. Okay. HSM added this one ribbon, so this is really the focus of our training. And you can see why it doesn't really have to be 3 or 4 days. It's very easy to use. It has its own help system that comes with it that's unique with Inventor HSM. It has a YouTube channel. If you need to go and look at some movies or something, you can do that. And then we also have training classes that we do quite a bit on. So what we'll do is, first of all, we're going to remove, we have a big hunk of box of steel here, and we're going to remove this out to get our part in shape. So I'm going to use the adaptive feature of HSM, which really makes it unique. And I'm going to go down into the sample tools area, and all of these sample tools come with the product. So you don't have to waste a lot of time building tools from scratch. And I'm going to go out here and we'll grab this 1/4 inch, maybe a 1/2 inch flat. And you can put shanks on these, and I could spend a couple hours just on the tool library. But it does include holders. Maybe we'll take a look at some of those. You can look at the holders, and you can use holders, which is nice for interference checking, right? You don't want to bump into a holder. It also does include probes. And while this presentation is focused pretty much on the milling side of it in Inventor HSM and AnyCAD, it does include a library full of turning tools also, where you can go into the turning tools and edit the insert and so forth. Really easy to use product, and the user interface is awesome. So let me go back and grab a 1/2 inch flat. And I'll hit select, so the tool's loaded. From the geometry side, it already knows what the stock is. Okay, so the stock boundary, I could just say, it could be here, and the reason I'm doing that is for these round corners so it doesn't machine down through there. The height is defined by the solid. I can come in and control the maximum depth of cut. Maybe we'll say 100 thousandths or something, and then we'll pull the trigger on that, and adaptive goes to work and looks at the Solidworks model inside of Inventor and produces toolpath to machine out that shape. And actually, I don't care for that. So I'm going to go back in here and edit. So it's just a double pick edit. And we're going to grab a little bit smaller tool. And maybe we'll grab a 1/4 inch instead. And hit OK. You can see changing is just as simple as a double pick edit. And it will produce a different tool path on that. Goes and calculates its way through there. I still don't like the way it's coming down on this edge, so I'll double pick edit. Turn off rest machining. And we'll do the stock contour again and see if we can get this to work the way I want it to. And hit OK. And that's really what I like about it, is there's different fields and different values and stuff, and as you're learning, you're going through that. You just double pick edit and make changes from within the parameters and watch what happens and learn that way. So really, in just a matter of a few minutes, and I could have done it faster had I not been explaining things, we were able to go in here, and let me just real quick double pick edit this because I don't want to leave any stock. So I'm going to turn off the stock. And then we'll go ahead and just simulate this for you. Turn on the toolpath, yes or no. Turn on the stock, yes or no. I'll turn on the stock and hit the play button. And what you'll see is the toolpath that it's generating. Hopefully you can see that okay on your screen. To machine out this part that we linked with the Solidworks model. So we're actually machining on the Solidworks model. Very quickly create toolpath. I have a couple slots over here that the tool wasn't able to find its way in on. So we'll go ahead and we'll do another operation here. We'll do a 2D contour operation, and I'll go get a little bit smaller tool from my sample. You'll notice that when you pick it from the sample, it brings it forward. Let's go with an 1/8 inch. Where are you at? Here we go. It brings it forward right into the library of that part so that you don't have to continue to go and hunt and peck for things. So we're using that tool, and this is neat too, a little tip and trick here. It says selected contours, but once you're familiar with the product, you'll know on the heights tab that the default bottom height of this operation is the selected contour. So I can pretty much kill two birds with one stone here by picking the contour on the bottom, because the height is being defined at the same time. So we'll just hit OK, maybe make sure I'm not roughing anything there, and very quickly we can rough that out. And there's the tool path for that. So again, a couple quick simulations. Pick it up here a little bit just for the sake of time. Yep, got to do those pockets, so I'll let it continue to roll. And you don't have to sit here and watch this. You can hit this button here with the dot, and it'll take you to the different operations, and I might do that next. So there we go. And lastly, I'm going to do a little chamfer. This is new. I don't know if you're using it now. I believe it was 2016. That might have been 2017 that they added this. So we'll do the chamfer operation. I don't know if I have a chamfer in here or not. Nope. Well, we can define a chamfer. No, I'm going to go steal one. I have a part here that I have done in the past. So check this out. I'm going to go to the tool library on this part. I'm going to grab that chamfer and right-click and copy. And go to the other Solidworks part and right-click and paste. Whoops. So it's in here now. And then we'll go back to our Solidworks part, do the 2D chamfer, and grab that tool that I just stole from somebody else's part. And that's the nice thing about the tool library is copy and paste, just like Windows. And on the geometry here, we'll just tell it to please go ahead and chamfer that corner and maybe that part there too. And when we go to the passes, we have now a chamfer area where we can define the size of the chamfer. I'm just doing 10 thousandths, pull the trigger, and it does its thing. And again, I mentioned the simulate, where we don't want to watch the whole thing simulate. If you hit this dot, it'll just take you through the first operation and knock that out for you. And now we want to see what happens. So now we'll hit the play button. Does the slot and then the chamfer. And see how it stops here? It knows that it's not going to, it doesn't want to run into that area there. So just smart software. And now what happens? The phone rings. We've just got this thing all programmed, right? And the phone rings, and what do we get? We get an engineering change. That's just part of life, right? So again, to focus a little bit on that Inventor AnyCAD again, what I'm going to do is I'm going to go back. I'm going to change hats. I'm going to be the engineer, and I'm going to go back to Solidworks. And one thing I want to point out here on the Inventor side is there's this little grayed out button. It's a local update, and it's grayed out because there is no update needed right now. Just remember that here in a second. Excuse me. So we're going to jump back in, put on a different hat, go back into design, and go back into SolidWorks. I'm the SolidWorks user. I'm either next door or across town or across the country, and I need to make a change to this part. And for the sake of, a presentation, I'm going to make it one heck of a change. So let's double pick and let's change this sketch and make that guy there maybe 4 inches. And update that. This boss here, this sketch, there's another one. Yeah, this guy here, this needs to change. Maybe we should make that 1 inch or maybe 0.75. That looks pretty good. So we've made a couple changes to this part. We've extended the boss, and we've made the part very big. Okay. So the engineering change has taken place. The guy saves his model, and what does he do? He emails it to you or loads it up on the cloud or something like that. And you snap your fingers and go, well, shoot, I was all done programming it. Well, because we used Inventor AnyCAD, and when we opened up this model, we didn't import it. We instead kept it linked to the SolidWorks file. We now get a notification up here that the part that this is linked to, the SolidWorks part that this is linked to, has changed. So we click on that button, and now we see the new model. So it's changed. And again, I want to emphasize, this doesn't have to be SolidWorks. It could be, Pro Engineer, CATIA, anything. And this Inventor AnyCAD is a big deal for clients that work with contractors or other people's files. So the part has been updated. On the CAM browser, our operations now have a little red X in them, and that's our visual aid from an NC programming standpoint that this operation, or these 3 operations, are no longer up to date. Well, how do we fix that? We simply pick one button, and it will go through and regenerate these tool paths. And what we're going to look at, obviously, is the adaptive tool path is going to now machine the area because it's tied to the geometry. Right? So we got brand new tool path, brand new cycle times, new G-code. But what's also interesting here to point out is the 2D contour. Remember how I pointed out that when it came in here, and let me just simulate this, it might be easier to explain. Turn off the stock. That when that comes in, It does the top first. Okay. But whenever it does the lower area, it knows that it doesn't want to bump into that boss right there. See how it avoids that boss, goes around, and it will come on down and avoid there, lift up. So this is the smarts of the software. Now you, as the programmer, control that. Okay, so that value there, if we go back into the 2D chamfer, is this chamfer clearance. And from a learning perspective, we go, well, what does this mean? And this is, again, where Autodesk has done a wonderful job with the user interface, is if I put my mouse right there, I get a pop-up on exactly what it is. So that's the value that specifies how far the tool needs to stay away from any model geometry that's not being chamfered or that it may bump into. So we can go back, we can pick up the phone and call our friends that we're doing business with and tell them, you know, this boss that you changed has kind of caused us a problem with this 2D chamfer. Was that necessary? And they can say, oh no, it wasn't really necessary. We'll go back in and we'll change that back. Is that a problem for you guys? Okay, well, other than I've just programmed the darn thing, no, it's not a problem. So we can change that. They save their file. I'm over in Inventor. I've got my little local update lightning bolt. I hit that. The boss changes. One button to regenerate the tool path. And here within, you know, just really a few seconds, your tool path has now adjusted so that it does go ahead and machine around that chamfer. So again, just to reemphasize, the AnyCAD feature is Inventor. So if you're dealing and working with clients that have different CAD systems, you know, Solidworks, CATIA, Pro Engineer, you don't have to import that geometry. You can leave it linked to the original file, and if they email you a new file and you plop it down in the same folder as the other file, it will notice that there's a timestamp change, and you'll get your little yellow lightning bolt. So it's not just manufacturing. We see it in assemblies. You know, you're putting together an assembly, but you buy this part and you buy this part, or you're putting together an assembly and you have a contractor that builds this part in Pro Engineer. When you bring those into the assembly using the AnyCAD, you just keep them linked, and if those parts change, all you have to do is hit the update button from within Inventor, and it'll update to the new model geometry. So I wanted to have this presentation really focus on that, that it's not just, you know, Inventor HSM thing. It's Inventor, it's Inventor assemblies, FEA models, right? If you're doing some Inventor Pro FEA work, that would also be impacted. So it's not just the manufacturing, but it really is great teamwork within the Inventor and HSM. Now from here, just to finish up, for those of you that are not familiar with HSM, just a quick look at the questions. All good there. Once you have a program and you have it the way you want it, we're going to go ahead and generate a setup sheet. And I like this feature, and maybe it's because I'm a little old school, but this was something that we would print out, and it would follow the part through the shop. So the setup sheet, it's an HTML file, and it produces information about the part. It shows a description of all of the tools that are being used, and it even gets into cycle times. So it shows you the cycle time, and then you get the total cycle time of the part itself. So this is something that's big, and it's nice to have this follow the part as it goes through the shop, in case it goes to milling and then heat treat and then turning and then back to milling. Just have it follow the model. Now that we've got that, we'll go ahead and we'll produce code. That's the post process button. And this is what I wanted to point out, and I mentioned it a little bit earlier, is that the list of available post-processors that come out, that are part of the software when it ships is quite impressive. And just leaving this up here a little bit, we're recording this session also, so you can refer back to the recording if I go too fast here. But you'll see that your basic machines are in here. We even have a dump file which helps us debug and helps with post-processing. But typically your Fadals, your Fanooks, your Mazaks, your Haas's, Heidenheims, Mazatrolls even in here. I mean, I can remember in the earlier days Mazatroll gave us fits, but not nowadays. We have our Morisiki, Okumas, so they're all here. And one thing, just if there's anybody really old school out there, there's even an app one in here somewhere. There it is. APT, now that goes back into the 80s, my friends. So they've got it all. They've got it all. So anyway, let's just go ahead and post this out. We'll just use a generic Haas, if that's all right with you guys. Hit the post. And now when you do that, it automatically pulls up the editor, and you can see your cycle time. And this editor, obviously, it's included with the software. But again, a nice place where Autodesk has taken into consideration the user. Color-coded, I can see where my tool change is. I can see where my rapiding is going on. I can see here a GO1 switching to GO3 just by color code, which is nice. Oop, there's a rapid, another rapid back into position. So the editor is really, really nice here. Makes life a lot easier from an editing standpoint if you need to. Obviously the objective is not to edit, but you can also use the editor to add in your own NC functions. You can renumber things. You can even change speeds and feeds throughout, and that would be an example of where you're thinking you're machining in aluminum, but lo and behold, you read it wrong and it's steel, and you just want to make a quick change through all the speeds and feeds. You can do that here. You can also generate statistics on the toolpath. Here's your cycle times. Again, and your quoting department are going to like this because you can make toolpath real fast and just to even generate a quote before you get the gig. So HSM has been used in that manner also. We have a back plot, so if you have some old programs and you don't know what the heck they do, you can open them up here and run them through a back plot window, and it'll show you basically what the tool path is, and from there perhaps you can figure out better what part that was for. You can compare files also, and we ran into this quite a bit where I grew up, I guess, is we would send programs out to the machine shop, but they had the flexibility to make adjustments if needed right there at the control. So from here we can do a compare. So you can compare another file with another file. So what would happen is they would send it back, so we would have a going out folder and there would be a coming in folder, and we could compare the two files and see what it was that they changed, and then go back into our program and see if we can tweak it so that the next time they run it they don't have to do any comparison. So transmission, we can send and receive right from this computer or right from your computer. If you have everything set up, there is a quick setup that you need to go through that might talk about your basically your port, stop bits, parity, baud rate. This might be Greek to some of you. It might be very familiar with others. But this is basically the communication parameters, maybe from the back of your RS-232 port hardwired out to that port. A lot of people nowadays are just using network solutions to take care of that. But let us know if you need help there. We would be happy to help also. And then you can build your own macros here too. So I think we ran into one was honing. We're not very slick on honing right now, but if you need to do a honing operation, we could come in here and add some spots and what code is needed. I can just double pick on that and it would enter in the honing area. You can type in the diameter of the stroke and have it produce the code for you right here. So again, just very, very simple to use and operate and learn. So go ahead and close that here. So with that, I've run into, there's about 10 minutes left here. I just want to reiterate, if I may, this slide right here. Our training options. You'll notice on our website, it's www. My kids still make fun of me for saying that, but Hagerman.com, and on there you'll find a training catalog. You'll find a list of classes that are available, and you won't find HSM. You go, what the heck? The Inventor HSM training that we do, it's company focused. It can be very short, one day. We're going to do one tomorrow here in Hoffman Estates. Doesn't take a lot to learn the product, but it is what we refer to as custom training. So we've decided not to mix multiple companies into the same class. So if you go on and hook up with Hagerman for your training on HSM, it will be company specific for your needs. And send us a file if you want us to look at a file ahead of time. That would be great, and we'll apply that training to what you need. We're not going to waste your time there. So with that concludes my presentation. I'm going to go ahead and jump into the questions. If anybody has a question, I see one. Let's see if I can read it by opening this up a little bit. Yeah, the HSM product, it can be downloaded. If we go back to a web browser here, I'm just going to go to cam.autodesk.com. And a lot of times I don't worry about that. I just search Inventor HSM. And I've got all these windows on the screen here, so bear with me. So you go to cam.autodesk.com. You have the products here that are available to you. There is a free HSM version. It just does 2.5 milling. It doesn't do turning or anything like that. But if you go to the download links, here's where all of the products are. And I did want to mention, based on this question, if I understand it correctly, the AnyCAD is included in Inventor. You don't need HSM for AnyCAD. Okay, so you have AnyCAD if you have a current version of Inventor. Okay, for the HSM download, you just go to cam.autodesk.com, go to downloads, and here are the different products: the Express, the Inventor version. You can also, we can help you with this, but there's the distributed CAM, and this is kind of risky for me, but there's also development versions available if you want to, if you live on the edge and you want to play with it or start working with the development version, you're more than welcome to do that, but keep in mind that these are development. They haven't been released yet, so they haven't gone through the same quality control that the released version has. So there's HSM Express. So yeah, just let us know, and we'd be happy to help you with that too. Let me get this window out of the way. HSM Express. Distributed cam. And you can just download it right now. Simple as that. It's kind of big, not terrible. But Inventor and HSM bundled together is about maybe a little over 3 gigabytes. So, any other questions from anybody? It's been quiet. As Ashley mentioned, it's being recorded, so if I miss your question, I apologize, but I don't think I have. So, Ashley, I'm going to turn this back over to you to wrap things up. And again, thank you very much, everybody, for your time.
Well, thanks, Tad, for the presentation. And if there's nothing further from anyone, this will conclude our broadcast. If you do think of additional questions, you can simply reply to the confirmation or reminder email you receive from GoToWebinar. We can get those to Tad or the correct person to get your questions answered. Once again, if you could take a few moments to fill out the survey, we would appreciate it. It will just pop up as we close down the session today. And thank you for attending the webcast, and have a great day, everyone.